In this video, we're going to continue topic 5.6, which is concavity, and we're going to look at example 7. So the graph of h prime is above, so I'm starting with the derivative graph. On which open intervals is h decreasing and concave up? So I have to look at decreasing plus concavity, and we're supposed to give a reason for our answer. So what we're going to do is what we call a double layer sign chart. And we're going to write down not only our critical numbers, so I'm seeing my critical numbers there in blue, but I'm also going to include anytime I have a horizontal tangent in my sign charts. I'm going to also include the places where I highlighted kind of in pink there. So I'm just going to go straight from my sign chart, set up my intervals. It looks like we're closed there. So we are looking at starting at -2. My first critical number is at 0, so that's my first fence. My next critical number is at 2, so there's my next fence. My next one is at 3. My next one is at 8. My next one is at 9. And then my final one is at 11. All right, and then let's talk about what's going on with the first derivative. Okay, and then the second derivative, and then ultimately what is going on with the original function. So when my first derivative is above the axis, we are positive, okay, in this first interval. Then it goes in between 0 and 2, it's below the axis, so it's negative. In this one here, it's below the axis still, so it's still negative. Between 3 and 8, it's still below the axis, it's negative. Between 8 and 9, it's still below the axis, it's negative. Between 9 and 11, it's above the axis, it's positive. So in this row, to get this row, we look at whether the graph is above or below, okay? To look at the second derivative row, we're going to look at whether the graph is increasing or decreasing. So between 0 and 2, I am decreasing, so it's negative. Between -2 and 0, it's decreasing. Between 0 and 2, it's still negative, so I'm decreasing. Between 2 and 3, 5, I wrote a typo there, didn't I? That's supposed to be a 5. All right, between 2 and 5, it is increasing, so it's positive. Between 5 and 8, it's decreasing, so it's negative. Between 8 and 9, it's increasing, so it's positive. And between 9 and 11, it's increasing, so it's positive. So now let's go back to what let's just read this. So positive means increasing, negative here would be concave down. So actually let's do that. Anywhere where it's positive would be increasing, right? Anywhere where it's negative in green would be decreasing. Anywhere where it's negative here would be concave down. Concave, oh, what did I do? That was concave up. Concave down. And anywhere where it's positive would be concave up. All right, let's go back to what it was asking us to do. So it wanted decreasing and concave up. So decreasing, concave up, notice my signs are opposite right there. Decreasing and concave up, and another decreasing and concave up right there. So we want to write that out. And they didn't ask us to justify, it does say give a reason for your answer. All right, so H is decreasing and concave up on 2 to 5 and 8 to 9. And we're using the open parentheses because we're talking concavity. Because F prime, and remember that's what I had, so my explanation kind of needs to be based on F prime. F prime is less than 0 and decreasing. And if you really want to overkill it, you could say that It's not decreasing and increasing because it's going up, right? The plus sign there means it's going up. So and increasing, and f double prime is greater than 0 on these intervals.